Welcome to this video on acids, bases, and salts, designed for 10th grade students. This session will cover fundamental concepts of these chemical substances. What is an acid? Acids are substances that taste sour, turn blue litmus paper red, and neutralize bases. They have a pH level of less than 7 and are classified as either weak or strong based on how completely they dissociate in an aqueous solution. Conversely, a base is a substance that is bitter in taste, has a soapy touch, turns red litmus paper blue, and neutralizes acids. Bases have a pH level greater than 7 and are also categorized as weak or strong, depending on their dissociation in water. This table summarizes the physical properties of acids and bases, including their typical colors, tastes, tactile qualities, and solubility in water. In chemistry, understanding the reactivity of these substances is key. We will explore how acids and bases react with metals, carbonates, metal oxides, and how they interact with each other in neutralization reactions. When acids react with metals, they displace hydrogen atoms to form salt and hydrogen gas. Alkalis, which are water-soluble bases, also react with certain metals to produce salt and hydrogen gas. Metal carbonates and bicarbonates react with acids to produce salt, carbon dioxide, and water. Notably, bases do not react with metal carbonates or bicarbonates. Metallic oxides are basic in nature. When they react with acids, they produce salt and water, a process that reflects the basic character of these oxides. Non-metal oxides are generally acidic. They react with bases to undergo a neutralization process, resulting in the production of salt and water. Neutralization is the specific reaction between a strong acid and a strong base, which results in the formation of salt and water. Indicators are substances that help us determine if a material is acidic or basic by changing color. These are categorized into natural, synthetic, and olfactory indicators based on their source and how they react. An alkali is a specific type of base that dissolves in water. They are typically bitter, soapy to the touch, and have a pH greater than 7, with distinct properties such as being soft and reactive with halogens. When diluting an acid, caution is required because the process is highly exothermic. Acid should always be added slowly to water with constant stirring to prevent splashing or damage to containers due to excessive heat. The pH scale is a universal indicator used to measure the concentration of hydrogen ions in a solution. Ranging from 0 to 14, it identifies solutions as acidic, neutral, or basic. Finally, this chart illustrates the pH scale with common household substances, showing how their placement corresponds to their acidic or alkaline nature. In this section of the video, we explore how pH affects our daily lives. Many living organisms are sensitive to pH, and our bodies require a specific range to function correctly. We also look at how acid rain occurs when the pH of rainwater drops below 5.6. Plants also require an optimal soil pH, typically between 5.5 and 7.0, for healthy growth. Both excessively acidic and alkaline soils can restrict the availability of essential nutrients, potentially hindering plant development. Our digestive system uses hydrochloric acid for food breakdown. However, during indigestion, an excess of this acid can cause discomfort. Antacids, which are basic, are used to neutralize this excess acid. Tooth decay is also linked to pH levels. When mouth bacteria produce acids that lower the pH below 5.5, it can damage tooth enamel. Brushing with basic toothpaste helps prevent this. Plants and animals have evolved chemical defenses. For example, stinging nettle leaves inject methanoic acid, and certain bee stings cause pain due to the acid injected. Baking soda is often used to provide relief. This section highlights various naturally occurring acids found in everyday substances, demonstrating their presence in the world around us. Salts exhibit several characteristic properties. They can be acidic, basic, or neutral. They conduct electricity in solution, and they generally form hard, crystalline, non-volatile solids with high melting points. Common salt, or sodium chloride, is formed from hydrochloric acid and sodium hydroxide. It serves as a vital food preservative and a primary raw material for various industrial chemicals. Caustic soda, or sodium hydroxide, is produced via the chloralkali process, where electricity is passed through a brine solution. It is essential for making soaps, detergents, paper, and for degreasing metals. Bleaching powder, chemically known as calcium oxychloride, is produced by the action of chlorine on calcium hydroxide. It is widely used for water purification and as an oxidizing agent. Baking soda, or sodium hydrogen carbonate, is produced from sodium chloride, ammonia, and carbon dioxide. It is commonly used in kitchens to make food crispy and in fire extinguishers. Washing soda is sodium carbonate decahydrate. It is produced by adding water molecules to sodium carbonate and is primarily used for softening water and as a general cleaning agent. Plaster of Paris, or calcium sulfate hemihydrate, is made by heating gypsum to 373 Kelvin. It is commonly used in medical settings to support fractured bones and in decorative arts. Thank you for watching this educational video on acids, bases, and salts. We hope this summary has helped clarify these important chemical concepts.